Welcome back, geometers. In section 3.3, we're going to finally get to do some geometric proofs. You guys have had some experience with algebraic proofs, but now we're going to do some geometric proofs with parallel lines. And we're going to use theorems and converses. So you have to recall what a converse is. So in chapter 2, you guys learned about logic, symbolic logic, and you remember that what a converse is. If you don't remember, it's okay. We're going to warm you up and refresh your memory. So I have 3 warm-up questions, and basically I just have 3 statements, and one at a time what I want you to do is write the converse of the statement that I give you. Okay. So number 1, if an angle's measure is 45 degrees, then it is acute. Okay, and so let me just refresh your memory. This is called a conditional statement. If something, then something. This is called the hypothesis. If the hypothesis, then, and this is called the conclusion. Okay, and we use the letter P for the hypothesis, arrow Q. So P implies Q, right? So remember that the converse, you simply just switch the Q and the P. You write a new conditional statement where Q implies P. So go ahead and take a shot at that. Okay, so switching the Q and the P, we get if an angle is acute, then its measure is 45 degrees. Now, don't worry about the truth value of these 2 statements. We're not evaluating the truth value of these statements. We don't care about that for this exercise. We are just recalling what converses are and how to write them. Okay, number 2. If the sun is shining, then it is spring. So please go ahead and write the converse of that. If it is spring, then the sun is shining. And we just simply switched the conclusion and the hypothesis. Okay, number 3, if a fruit is ripe, then it is sweet. Okay, the converse is, if a fruit is sweet, then it is ripe. So conditional statements, we use this kind of notation. P implies Q, or if P, then Q, right? So P we call the hypothesis, and Q we call the conclusion. And with a converse, all we do is we switch the Q and the P. So the conclusion implies the hypothesis, okay? So in the previous lesson, we learned about 2 parallel lines cut by transversal, and we learned about the 4 angle pair relationships, right? And we learned these 4 theorems, and each one of these 4 theorems is a conditional statement, which really all theorems are. But let's evaluate these conditional statements pretty closely, okay? Theorem 3.1, the corresponding angles theorem. This says that if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So think for a moment, what is the P and what is the Q? And can we really boil down what the P is and what the Q is? So the P is that the 2 lines being cut by the transversal are parallel. Parallelness is the hypothesis. That's the given information. Okay, we're given that P and Q are parallel. See these red arrowheads? That's in the diagram. That means that's the given information. The conclusion is that certain angles are congruent, corresponding angles are congruent. Okay, same thing with all 3 of these first 3. If the lines are parallel, then congruent, congruent, congruent. Okay, and even in the 4th theorem, the hypothesis is the same. The given information is the same, that P and Q are parallel. Now your conclusion is slightly different. You don't have congruence as a conclusion, you have supplementariness as a conclusion. Okay, because that is what those angle pair relationships give you, CIAs give you. Okay, but in all 4 of these theorems, the hypothesis, the P, is always that the 2 lines are parallel. Okay, so now we're going to switch that around, and we're going to look at the converse of each one of these theorems. So the parallelness is no longer the given information or the hypothesis. The parallelness is what we're going to conclude in these converses. The given information is going to be corresponding are congruent, AIAs are congruent, AEAs are congruent, or CIAs are supplementary. Okay, so let's take a look. So again, conditional statements, P implies Q. In all four of those theorems, the hypothesis were the given information was that the lines were parallel. The conclusion was that the angle pair relationship was either congruent or supplementary. Now let's flip each one of those. To flip them, okay, we're just going to switch the P and the Q, right? And so now this given statement, this part is going to be given that the angles are blank, either if they're corresponding AIAs or AEAs, you're going to be given that those are congruent. If they're CIAs, you're going to be given that those are supplementary. That's the given. Okay, and now the conclusion is going to be that the two lines are parallel. So you're going to have the same diagram, but you're not going to have these red arrowheads, okay? Because you're not going to know necessarily that P is parallel to Q. That's what you want to conclude, okay? All right, so let's go through these one at a time. Okay, so there are four of them. First one is corresponding angles theorem. And let's take the converse of the corresponding angles theorem. So this simply says that if you have this situation like this, if you have two lines cut by transversal such that corresponding angles are congruent, then we can conclude that the two lines are parallel. Then M is parallel to N. Notice we don't have the arrowheads because we don't know if they're parallel. But if it is true that the corresponding angle pairs are congruent, okay, then we can conclude that M is parallel to N. Now, the way this theorem is written, it makes it sound like you have to know that all four pairs of these angles and these angles, all four pairs of corresponding angles are congruent. Okay, that is not the way that we're actually going to utilize this converse. As long as we know that one pair of corresponding angles are congruent in a diagram like this, that is enough for us to conclude that yes, the two lines are parallel. Okay, and technically we could go through and prove that if one pair of corresponding angles are congruent, we could also prove that all four pairs of corresponding angles are congruent, but you're not required to do that to use this converse. All you need to know or identify or figure out is that one of these pairs is congruent. That's enough to conclude that the two lines are parallel. Okay, so let's write that out. So I like this diagram because the angles are color-coded. So for example, if the red angles, those are sitting in corresponding positions. Okay, if angle 1 is congruent to angle 5 in this diagram, that's enough to conclude that line M is congruent to line N. Okay, same thing with, if you know the purple, if 2 and 6, if angle 2 is congruent to angle 6, that's enough for you to conclude that line M is parallel to line N. Same thing with 4 and 8 or 3 and 7. Okay, you don't have to have all four of those, you just have to have one of those. All right, so now let's look at the alternate interior angles theorem and its converse. Okay, so the converse would say if two lines are cut by a transversal such that the AIAs are congruent, then that's enough for us to conclude that the two lines are parallel. So again, we have color-coded angles. So you have this orange angle, this big obtuse orange angle, and we're given that its measure is 116 degrees. Then you have its alternate interior angle, this orange shaded angle, its measure is also 116 degrees. So if we know that two angle measures are equal, then we can conclude that those two angles are indeed congruent. And if those two angles are congruent, since they're sitting in alternate interior angle positions, that's enough for us to conclude that line KO is going to be parallel to line LN. Okay? And the same thing is true for these light blue angles. Okay? All right, so now I think you're really catching on. So now the AEAs, okay, alternate exterior angles theorem, same thing. Its converse is simply, let's look at one pair of these, and I think I chose the greens. Okay, if angle APX is congruent to angle DQY, so if these two green angles are congruent, then that's enough for us to conclude that these two lines are parallel. Line AB is parallel to line CD. So that's the way that these converses work. And then the final converse is the converse of the consecutive interior angles theorem. So I color-coded the CIAs blue on this side and red on this side. So again, you just need to know one pair of these. Okay, if you know that angle 1 and angle 2 are supplementary, okay, that's enough for us to conclude that line AB is indeed parallel to line CD. Okay, so when do you use a converse? When you're asked to prove that two lines are parallel. Two lines cut by a transversal are parallel. Okay, let's go through some examples. So here's probably the easiest example. So example 1, find the value of x that ensures that line M is parallel to line N. State the theorem used. State the theorem used. Also, I want to address this notation. Some of you might be thinking, hey, why does this line M not have a line symbol above it and line N does not have a line symbol above it? When you're using the notation for a line that is just one lowercase italicized letter, like this right here, okay, you do not necessarily have to put a line symbol above it. It's understood that this represents the entire line, okay? Now, you're not going to lose any points if you put a line above that. In fact, if you want to be, extra safe, extra sure, it might just make sense for you to just put a line symbol above that. Remember, the line symbol has 2 arrows, one on each side, okay? State the theorem used, okay? All right, so what value of x ensures that these 2 lines are parallel? Well, first of all, look at these 2 angles, and what position are they sitting in? Those are corresponding angles. They're sitting in corresponding positions, right? Upper right and upper right, okay? So if those lines are parallel, we know that these 2 angle measures would have to be congruent, okay? So go ahead and set up the equation. 3x plus 5 equals 65. Subtract 5 from both sides, divide by 3, so x equals 20. So when x equals 20 and no other value, if x equals exactly 20, okay, then these 2 measures are equal, therefore their 2 angles are congruent, therefore the 2 lines are indeed parallel. What is the theorem we used? We used the AEA converse, okay? Now you can write it out as converse of the alternate exterior angles theorem. You can abbreviate it like that. You can always abbreviate angles with this angle symbol, okay? Or it is acceptable to simply write capital A, capital E, capital A, converse. But, caveat, warning, do not just write AEA. That will be wrong. Okay, if you're justifying this, it is the AEA converse. You have to have this word converse, okay, because AEA is the alternate exterior angle theorem, which is completely wrong. It's the opposite of the AEA converse. So that is why you would get it wrong if you simply wrote AEA as a justification for 2 lines being parallel. You have to have the word converse if you're using the converse. Okay, now let's actually get into a proof, okay? Let's prove the AIA converse. Let's prove the AIA converse. So now here's the deal. Remember that postulates are something that we don't prove, right? We just use them, we accept that they're true, okay? But theorems and converse of theorems, we can always prove, and we really should. It is very good practice to prove every single theorem and every single converse that we use, okay? And the book actually does that. The book actually provides a proof for every single theorem that it provides, okay? And it's a good idea for you to go through those. In this course, we're not going to make you prove every single theorem, okay? But we are going to make you prove some of them, okay? So I would say that it's very good practice, hint, hint, for your assessments, hint, hint, to go ahead and work through, anytime you're presented with a new theorem, work through the proof of that theorem or that converse, okay? I've taught this course for many years, and I will tell you that teachers love to include those kind of proofs on exams, on quizzes, on final exams, and that kind of thing. Okay, so let's prove the alternate interior angle converse. Okay, so here is the alternate interior angle converse. So we're given a diagram like this, and we do not know that these 2 lines cut by this transversal, we do not know that G and H are parallel. In fact, that's what we're trying to conclude. That's what we're trying to prove. Okay, so here's the diagram. Here's the given information. We're given that angle 4 is congruent to angle 5. And we're asked to prove that the 2 lines are parallel, that G is parallel to H. Now, when you're proving the AIA converse, you cannot use the AIA converse as one of your reasons. That is now off the table, okay? But you can use every other theorem and every other converse. So to prove the AIA converse, You could simply use, oh, I don't know, the corresponding angles converse, or the AEA converse, or the CIA converse, okay? So all of those other converses and theorems are on the table, but the AIA converse, since that's what you're proving, that is off the table. You cannot use that as a reason. Okay, so remember that when we're doing proofs, we are doing what are called two-column proofs. We're not going to make you do paragraph proofs or flowchart proofs or anything like that. We're always just going to do two-column proofs. So you have to set up the two columns, otherwise it's no longer a two-column proof. Okay, you must follow the conventions to get full credit for your proofs. Okay, so you're going to have statements on one side and reasons on the other. Okay, statements on the left, reasons on the right. Follow the convention. Okay, you must, for every statement, you must have a corresponding reason. Okay, also, you must number your statements and reasons. Okay, you must have number one and number one for its corresponding reason. Okay, the reason for that is, again, that's a convention for two-column proofs. If you do not have that, you will not receive full credit because you have not followed the convention. Okay. So statement one, you don't have to start with a given, but one of our strategies is it's really nice to start with a given information. Okay. So statement one is angle 4 is congruent to angle 5. The reason for that is that was given. Okay. Also mark that in the diagram, but it's already been marked for you. You see these arcs? These are congruence arcs for angles. It's been marked. If those are not marked in your diagram, go ahead and mark them. Okay. It will help you with the proof. These first few proofs are going to be like, 4-line proofs, super easy, super simple. But as we move on, progress in the course, we're going to get like 8, 10, 12, 15, maybe 20. Who knows? Proofs can get really long. In fact, mathematical proofs, there's entire books that are, just a proof of one particular concept. Okay, so proofs can get very, very long. So it is very good to mark your diagram as you go. It will help you follow where you're at in the proof. Okay, it will also lead you to the next step in the proof. Okay, so a strategy is when you're doing these kind of proofs, where you're using two lines cut by transversal, okay, you are going to link those two angles to a third angle. Link them both to a third angle. And the authors have already told you which angle to link them to. You don't have to use this angle. But this is a very nice angle to use, and the authors have already marked it, angle 1. So we're going to link both angle 4 and angle 5 to angle 1. Okay, so let's look at angle 1 and angle 4. What type of angles are those? What position are they sitting in? Okay, forget about 5 for a moment. Just look at 1 and 4. Well, those are vertical angles. And the vertical angle theorem that we learned tells us that vertical angles are always congruent. So now we know that angle 1 is congruent to angle 4. Okay, and I would go ahead and, I didn't do it for this slideshow, but I would go ahead and mark a congruence mark right there after you've proven that those two are congruent. Okay, what is your reason? It's the vertical angle theorem. Now, it is acceptable to write VAT, capital V, capital A, capital T. That is acceptable. You could just write VAT. Okay, and we'll understand what that means. Okay. So now let's look at these two statements. You have angle 4 here, and you also have angle 4 here. You have 4 is congruent to 5, and 1 is congruent to 4. So since these two are the same thing, we can now conclude that angle 1 is congruent to angle 5. And what is that called? Where A is congruent to B, okay, and C is congruent to A. What is that called? That is called the transitive property, not of equality, but the transitive property of congruence. And so now look at that statement, statement 3. Now you know that angle 1 is congruent to angle 5. And those are sitting in corresponding positions, and they're congruent. So now you can conclude that G is parallel to H, line G is parallel to line H, because of the corresponding angle converse. So what did we do? Okay, when we're proving the alternate interior angle converse, what were the 3 strategies we used? Strategy number 1, mark your diagram as you go. Strategy number 2, link the two angles to a third common angle and figure out the relationships between those angles. Strategy number 3, instead of using the AIA converse, which is off the table, simply use one of the other converses to prove this converse. Okay. Okay, let's get to a little bit more complex diagram. Now, learners that are strongly auditory and kinesthetic and not so much visual, non-visual learners tend to really struggle with this diagram. Why? Because it gets a little bit confusing, because now you have two lines cut by two transversals, but the two lines cut by two transversals, okay, R and S are given to you as parallel, but P and Q are not given to you as parallel. Okay, so we want to go ahead and prove that P and Q are parallel. Okay, so you have to be very careful which theorems and which converses you're using. Okay, we also call this, it looks like a hashtag symbol, it looks like a tic-tac-toe board. Okay, so we call this the tic-tac-toe proof or the hashtag proof, or, it's basically just two lines cut by two transversals. Okay, so your strategies are going to be the same. All three strategies apply. Okay, but one more strategy that I'm going to throw in there for those of you that struggle visually, that get a little bit confused visually, is to block out part of the diagram that you don't need to use at that time. Okay, and I'll show you what I mean in just a second. Okay. So now we're given that R and S are parallel. We're given that these two are parallel. Okay, and if it's not in the diagram already, mark it, but they already marked it for us. And we're given that angle 1 is congruent to angle 3. So I would make little marks for 1 and 3, okay, because that's given information. We are asked to prove that P and Q are parallel. Okay. Now, if you look at angle 1 and angle 3, those are angles on different transversals. Okay, those do not have a direct angle pair relationship that we learned. Those are not correspondings, AIAs, AEAs, or CIAs. Okay, because they're sitting on different transversals. But the strategy is the same. We're going to link those two angles through a third common angle. In this case, the author's already identified, hey, use this angle right here, angle 2. Okay, so we're going to link angle 1 to angle 2 and angle 2 to angle 3, and that's going to allow us to link angle 1 back to angle 3, which is going to then allow us to say something or conclude something about P and Q. Okay, so here we go. So strategies, mark up the diagram with the given information. Okay, make sure you mark that. Next strategy, link the two given angles to a third common angle. Block out part of the diagram, there's a new strategy, and then use another converse or another theorem, okay, to prove whatever you're trying to prove. Okay, so here we go. So we mark up the diagram with the given information, okay. Now we block out part of the diagram, okay. So block out that part of the diagram that is visually just confusing and just focus on R and S and Q. So now we just have two parallel lines cut by a transversal, and visually this is very easy. This is much simpler to look at. Okay, so let's link angle 1 and angle 2. Well, what are those two angles called? What position are those two angles sitting in? Those are corresponding angles. They're both sitting in the same position, okay, relative to the transversal. So we can conclude, because we were given that R and S are parallel, we can conclude that angle 1 is congruent to angle 2, and that is the corresponding angles theorem. Now let's add back that part of the diagram, okay, that we're going to use. Okay, and forget about this for a second. Look at 2 and 3. Well, 2 and 3, okay, are congruent because of, look at these two statements. Look at these two statements. 1 is congruent to 3, okay, and 2 is congruent to 1. So you have angle 1 is common to both of these, so you can conclude that angle 2 is congruent to angle 3, okay, and that is the transitive property of congruence, okay, the transitive property of congruence. And now because 2 and 3 are congruent, okay, those are sitting, if you ignore this part of the diagram, these two, when you look at P and Q being cut by this transversal, these two are AIAs. And since they're AIAs and they're congruent, that's enough information to allow us to conclude that P must be parallel to Q. That's the AIA converse. Okay, QED stands for Quod Erat Demonstrandum, and it's something that is typically written at the very end of your proof. You do not have to write QED, but I thought it was kind of cool just to teach you and just to kind of show you. If you ever see in a math book, probably in your higher advanced math courses, if you ever see QED, you'll know what it stands for. It basically means that which was asked to be proven has been proven. It basically means we're at the end of the proof. Remember that 4 lines is not a very long proof, but like I said, sometimes these proofs get to be, 20, 50, 100, 300 lines long, and it's really nice to write QED. It's really nice for the reader to know, okay, we are done with our proof. Okay. Guys, that's all I have for you. Hope you enjoyed the lesson, and please enjoy the practice problems. There they are right there. You can screenshot that and let us know if you have any questions. See you in the next video.